Hello, welcome to Lesson 7 in our study of rational numbers, addition and subtraction of rational numbers. Okay, so let's get started right off the bat here with some classwork, quote-unquote classwork. And exercise 1 is real-world connection to adding and subtracting rational numbers. Okay, so here's a problem I want you to work on. Suppose a 7th grader's birthday is today, and she is 12 years old. How old was she 3.5 years ago? Now that is easy. I think many of you have it already figured out. But here is what I need you to do. Okay, write an equation and use a number line to model your answer. See? And again, I know some of you, and there are some of you, some parents as well, who think that maybe some of this is silly. It's like, doing more work than you need to. But in truth, it's just getting you ready. This is all preparation for how you're going to need to write out your answers eventually, and also how the things that you see will make sense to you. They should make more sense to you, knowing that all of them have some sort of context that they just don't make you aware of. So yeah, go ahead and do that, and I want you to go ahead and write an equation. Remember what we did in lesson 6, and then use a number line. Use number line with arrows. Those vectors that we used some lessons ago to model this problem, and then come back and let's see how you did. Okay, welcome back. Here's what I came up with, and hopefully your model and your equation look similar. As you can see with my model, I went ahead and I added a few little I added the little half markers too, the little small ones between the whole numbers. Okay, and again, we initially started at 0, and like I told you before, a 0 doesn't always need to be in the middle. I mean, we're talking only about positive numbers here. Yeah, we are taking away, but in terms of the numbers, we're staying on the positive side of the number line is really what I mean. We're staying on the positive side because we're talking about someone's age, okay? And people aren't negative years old, okay? They're only positive years old, so we'll stay on the right side of the 0. Therefore, I started mine at 0. So yeah, you can see that move forward, that one vector, the long vector that began here at 0 and ended here at 12, okay, and that's what the 7th grader is at this point, 12 years old, okay, and then starting at that 12, 3.5 years ago, okay, so this suggests the past, and the past is, can be considered a negative thing. Past is negative, and I'm saying it's like not a negative experience, but negative in the sense is that you are taking away in years. So we're looking in the past. We were younger, therefore the value of our age was less. Okay, so it is in terms, we're looking into the past where it's a negative, has a negative value. Okay, and then when we went back, therefore we went to the left, like kind of back in time in a sense. 3.5 years, we ended up right here at 8.5 years old. Okay, 8.5 was that point right there. And then when I did my equation over here at 12, okay, 12 because that's the age she was presently, and then again just staying true to this this idea of sums plus a negative 3.5, and that of course equals 8.5. Okay, so again, really helpful. Do these number lines, and again in this case you had to. Okay, you were asked to write an equation and use a number line to model your answer. That needs to be done when that is required. Okay, this example 1 here just kind of takes you through a couple of steps to get the answer to this to that problem we just did. A little bit different than what I had told you, because what they do here is they say place the tail of the arrow on 12. Okay, so there's the 12. And now the length of the arrow is the absolute value. Again, they're talking about absolute value here of negative 3.5. Okay, which is of course 3.5. All right, absolute value of negative 3.5, 3.5, because absolute values are always positive. But since the direction of the arrow is left, since you are adding a negative number, okay, adding a negative number, and again you're going to go 3.5. So I'm going to go 1, 2, 3.5 right there, and I end up right in the middle, right there again. So at 8.5. Okay, so yeah, and that's just one line, kind of a sloppy line. Excuse me. Not exactly why they have that there, but that is there, and hopefully that helps. Maybe, maybe not. Okay, so exercise 2 asks you to find the following sum using a number line diagram. Okay, so if you would, I'd like you to go ahead and do that with one line, just like I did here. So I want you to do that with the one line system. You could use those steps again, and go ahead and show me an equation as well. Okay. Okay, so if we were going to do it that way, we're just going to start at negative 2.5. Now be real careful when you're doing the negatives. When you start doing rational numbers down there with using fractional numbers, and with numbers with decimals, which are fractional numbers as well. But so negative 2.5, is between negative 2 and negative 3. So again, we have a tendency of wanting to go this way when we have like 2.5, for example. Okay, but no, negative 2.5 is right between those two. Okay. So yeah, so we're going to put the tail there, tail of the arrow, and then we're going to just go up 5. Okay, go up 5. So right there, that's 1, 2, 3, 4, 5. We're going to go up 5. So we end up right there at a positive 2.5. Okay, and that's 2.5 there. Okay, so this was again 5 units. And again, I determined the direction by the fact that that was positive. That Q value was positive. Positive meant right. All right. Okay, so again, starting at the 2.5 right there, between the negative 2 and the negative 3, moving up 5 to get to 2.5, a positive 2.5. Okay, and how does that look as an equation? Well, it would look like this. It'd be negative 2.5 plus 5 equals 2.5. Alrighty, continuing on to example 2. A asked you here, rewrite the difference 1 minus or 1 take away 2.25 as a sum. Alright, and that would look like this. You're just adding your 1, then your plus, and then again that negative 2.25. I might have said 2.5 before, but I meant 2.25 in the parentheses to separate it out, so you can tell that it is indeed negative. All right, no confusion there. All right, and what they tell you to follow the steps using this one. They're saying this is going to be easier. So I should probably number these, huh? So let's just say it has to be 0 here, and let's just show you here too. Now we have a number line. We can really determine, as long as these segments here, all these segments are the same. Okay, they are equal. We can determine what we want each one of those to equal. All right. So in this case, when I have numbers like 1 and up to 2 and 2.25, or negative 2.25, I'm just going to go ahead and let these be fourths. Okay. 1/4, 2/4. I'm not even going to go to lowest terms, because that could be 1/2, but I'm going to keep it at fourths. Okay. 3/4, 4/4. Okay, and that's actually 1, of course, that's 1 whole. And then 5/4, which is 1 1/4. Okay, so I'm going to keep it in fourths. And going this way, I'm looking at negative 1/4, negative 2/4, negative 3/4. This just makes a lot more sense to me, and a lot more sense in this problem is to make each of these segments into fourths. Okay. All right. So again, just like they said before, you're placing the tail of the arrow on the 1. Okay. On the 1, and that 1, that positive 1 is right here, because that's 4/4. Also 1 whole, and then I'm going to add negative 2 1/4. Okay, but of course we're looking at the absolute value of negative 2 1/4 is equals 2 1/4. All right, so I'm going to move 2 1/4. I'm going to move to the left because it is a negative number. It's a negative move. Okay, so I'm going to go 2 1/4. So here we go. I'm going to go to 0. That's 1, and then I'm going to go over there to negative 1. That's 2, and then another fourth, which is right there. Okay, so that drops me off right here at a negative 5/4, or negative 1 1/4. Okay, negative 1 1/4. How does that look as an equation? That would be 1. Of course, we're writing these as sums, plus, actually we did this already up front, did we? Yeah, that's right, plus negative 2 1/4 equals negative 1 1/4. Okay, here for exercise 3, I'd like you to go ahead and just pause and do this by yourself, and come on back and check it. If you have any questions on these things, again, don't hesitate to ask in class, or to actually email me right away. Okay, just stop the video, get on your email, and send me a question. Okay. So here, your assignment here is find the following difference and represent it on a number line. So here it is. Okay, negative 5 1/2. Take away negative 8. Okay, so I want you to go ahead and do that. Model it on the number line, and then write an equation with an answer. Okay, go ahead and do that, and come on back. Okay, so if we go ahead and do that, just the way we were told to do that, we'd go ahead and put the tail of our arrow on negative 5 1/2, and that would be right about there. Okay, again, remember that negative 5 1/2 is going to be between negative 5 and negative 6. Okay, all right, because it's negative 5 1/2 is more negative than negative 5. Okay, so there we go. It's approximately there. My arrow's a little off, but anyway, now when I look at this, I have a negative. I'm going to subtract or take away a negative. And what we learned about that is that is the same as doing the opposite of a negative, which is a positive. So in truth, this actually could be written like this. Okay, so plus 8. All right. So I mean, if we were to think about it a different way, when you see negative, minus a negative, or take away a negative, right there, what we think, okay, here I am. I'm right at this point, and I'm saying, okay, and now I see this negative sign, and I say, okay, I'm going to head left. And then I look at another negative sign and says, oh, no, I'm going to go right again. Okay, so it's kind of like you're doing a little switcheroo. You're pointing this way, and then you point this way again. Okay, so you end up in the right direction. So we're going to move to the right 8 units, and that's going to take us to, here we go, 1, 2, 3, 4, 5, 6, 8. Okay, and that's going to get us over right there, and that is positive 2 1/2. Okay, we're on the positive 2 1/2. Okay. All right. So again, negative 5 1/2. That's where you start. Start right there. Okay. And then you're going to take away a negative 8. which is the same as adding 8. Therefore, I am moving to the right, and I do so, and I go 8 places, and I end up right there at positive 2.5. How does it look? It looks like this here, negative 5.5 plus 8 equals 2.5. Okay, so exercise 4. I want you to take about 10 minutes and complete these A, B, C, D, and E. Okay, and again, hopefully, at any given time, some of you have been just absolutely wonderful about this. You've been cutting little pieces of your graph paper and putting them in here, but you can feel free to just do them right on the graph paper. Maybe punch some holes in that graph paper and just slip it in behind this page, just so you keep it in order. But yeah, using the graph paper, using a ruler, highly recommend it. Of course, I'm not modeling that very well here, but it's difficult for me to toggle back and forth between pieces of graph paper, and using a ruler on this iPad just makes everything go crazy. So I'm sorry if I'm not modeling it, but I would really highly recommend that you use a ruler always, and use that graph paper. It makes it so much easier and so much nicer looking, and that does make a big difference. So I'd like you to take 10 minutes. Go ahead. You're going to find the following sums and differences using a number line model. Okay? Okay, here's letter A. Now I created this number line here, and what I did is I decided to separate it into 4 so it'd be nicer to look at. But as you can see, I don't even need to see my zeros over here now, because I don't need to bother. I know I don't need to bother with the right side of this number line, the positive side, because I can see I have a larger negative number than I do a positive number here. Okay, but I'm going to model that on a number line, which is what I asked you to do. Again, the tail of the arrow on that 6, because the negative 6, of course, negative 6, because that's where I'm starting. My first add end is. And then I'm going to head to the right, because I am adding. Okay, I'm adding that 5 1/4. It's a positive 5 1/4. Of course, I'm adding a positive 5 1/4, and I'm going to go that way. So I'm going to go. That is 1, 2, 3, 4, 5, and then a 4th. Okay, and I end up right there. So that is adding 5 1/4, and you can see where I end up right there, which is actually negative 3/4. Okay, because it's negative 3/4, because that's negative 1 right there. So a negative. So if I go fourths, I go there's 1/4, 2/4, 3/4. Okay, so that's negative 3/4 is where I end up. Okay, and of course, as an equation, it looks like this right here, and that just equals negative 3/4. Okay. Okay, so for letter B here, I saw that I had 7, and then the second number is only 9/10. I didn't really need a number line that had a wide variation of numbers, but I did want to account for the tenths. Okay, so I decided to go ahead and create tenths in between the numbers here, the integers. Okay. All right, so I did that. So, and again, just go ahead, just start. Tail of the arrow goes where? Of course, it goes right there on 7. Okay, and now I have again this scenario where I am taking away a negative, which means I am actually adding. Okay, I am adding a positive. All right, so that's going to become 7 plus 0.9. Okay, so then I just go ahead and add my 0.9, and I go there, and now I'm in tenths here, so I got 7.1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9/10 right there. So I've added 9/10, and where do I end up? I end up, of course, at 7.9. Okay, that's where I end up, right there. And that, of course, equals 7.9. Okay, and again, I've divided this up by tenths here. So I have 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, 10/10. Okay, so that's really important. How you, I mean, crafting your number line is just as important as anything, really, because it really helps you figure it out, and really it makes things easier to see. Okay, for the next one, you can see it's a little mix of rational numbers here. We have 2.5, and again, I saw 2.5 and I saw 1/2, which is actually the same as 0.5. I knew there wasn't much happening here, but I did like the idea of using gaps of a half, or using segments of 1/2, which I've created right there, as you can see. Okay, these are all 1/2 segments. Okay. Again, not much going to be going on the negative side, so I didn't really care. I don't even need it at all, actually. So I set my 0 far to the left so I can make more moves to the right. But anyway, with this one, 2.5, start there, and that's right there. It's 2.5. It's the same thing. Again, knowing your decimals, equivalents, and fraction equivalents, very important. We're going to add, therefore, a negative 1/2, which simply means go to the left 1/2. Okay, go to the left 1/2. That is negative, and we're going to do that. Boom, boom, boom. There it is. Where do we end up? We end up at 2. Okay, therefore 2.15, and we could write it out this way even. Not 2.15, 2.5 plus, and then if we wanted to match them up, just negative 0.5, which is the same as a half. Okay, and that of course equals 2. All right, see how those are, and those match up. Okay, D, negative 1/4 plus 4. Here we are at negative 1/4. Again, I've divided my my number line up into segments of fourths. Okay, fourths, so I can see it very clearly. This is my negative 1/4. That's where I start and head over 4. Okay, so I'm going to go over 4. So I'm going to go to, there is 1, 2, 3, 4. Okay. All right, I went over 4. So you can see I have, every time I hit a fourth there, so I was at just negative 1/4, and then I have to go over to 1, 2, 3, 4. Okay, over. That's going to be a whole right there. Whole. 1, 2, 3, 4 is another whole. And 1, 2, 3, 4, another whole. 1, 2, 3, 4, another whole. And then 1, 2, 3, 4, another whole. Okay, so I have added, of course, going to the right because of our positive sign. Okay, and yeah, and that could be sometimes a little bit tricky. It's probably easier to do it just in your head, I know, but showing on a number line, really important. Okay, you got to adding a series of wholes. 1 4 times, adding 4, we end up over here at 3 and 3/4. Okay, 3 and 3/4. How does that look? Well, I mean, in an equation, it just looks like that. 3 and 3/4. Nothing tricky about that, right? Okay. Okay, so our last one, E here, we start at 1/2, and again you can see I realized I didn't need the positive part of the number line because that's not 1/2 actually. I guess it is 1/2. That's 1/2 because I've actually created segments of halves, half segments. Okay, so that's negative 1/2, and then I'm going to subtract a negative 3, which of course is the same as adding. Okay, kind of, you see, you kind of join those two and then put something through it there. Kind of fun to think about that. Okay, so 1/2, and then we're going to actually add 3. So we're going to end up at, let's see, 1, 2, 3, right there, and we end up at 3 and 1/2. Okay, that equals 3 and 1/2. Okay, exercise 5 here for each one of these, and there's A, B, and C. Go ahead and create an equation and a number line diagram to model each answer. Okay, so I want you to model the answer and then give me the answer. Okay, because you'll see here in this first one, Samantha owes her father $7. She just got paid $5.50 for babysitting. If she gives that money to her dad, how much will she still owe him? Boy, they don't use really realistic examples here. Who would ever take $5.50 for a babysitting job? Anyway, here we go again. So you can see I would like an equation for that, a line diagram for that, and then of course the answer, which the equation I guess indeed will give. Okay, so go ahead and do those, A, B, and C, and come on back. Okay, so hopefully for this first one about Samantha and her father, you notice that this idea that Samantha owed him money is going to give you a hint as to where that $7 should be on the number line. Okay, and if you owe somebody something, that means that's a negative value. So here she is right here. It's at -7. Okay, it's a -7. So she's right there at -7 right now. She is what we say. Oh, I should draw this in red here. She is actually, this is actually a really good one to, actually I'm going to just do this again. I'm having some issues with my pen right now. I don't know why exactly, but I want to actually do this all in red. The -1, negative. You can see I already know when I drew this up that I know she wasn't getting out of the red. Okay, there's no black for this girl in this example. So anyway, here she is. She's sitting here at -7. Okay, right there. Okay, now I'll get black marker back. -7, but she got paid, and when you get paid, that's a positive thing. Okay, so we got so you owe, that equals negative. You know, and you get, and those are your debts. Those are things that you are indebted for. When you get paid, and that equals positive. Okay, money. We all love money, so hopefully this is going to be easy for you to figure out. But anyway, then she just got paid $5.50, so that's going to be a positive move. Okay, so that's going to be to the right. So if we go ahead and let's put our little 50 cents here, because those are half a dollars, right? Okay, and then we're going to go up there. We're going to go to $5.50, and there we go. We got 1, 2, 3, 4, $5.50. Okay, so $5.50 put us right there. So at this point, she's still in the red, like I had told you, but she's at the red now. She's -$1.50. Okay, she's at -$1.50. She's better. She's not as in deep a debt anymore. Any longer. She's no longer does she owe her dad $7, but she owes him now $1.50. Okay, so she's indebted to her dad. Okay, so B talks about a tank of gas, and again, it's interesting, but in terms of how some things can't be negative, the thing is you can never have a negative tank of gas in that sense. Okay, so this number line here represents how full or how many gallons are in this tank of gas. I don't need to go to the left of the zero, because I can't have negative gallons. The least I can have in that tank is 0, and I do not ever want to have that. So I'll just forewarn you, 7th graders, that and 8th graders, not to ever let your tank get so low that it's empty. Very, very bad for your tank. Very, very bad for your engine. Anyway, here we go. So at the start of the trip, the car's gas tank contains 12 gallons of gas. Okay, gasoline. So our tail of our arrow is right there. During the trip, the car consumes. Okay, this idea of consuming. When you consume, you take away. And again, consume is also a negative word in this sense, okay? Negative, to consume, take away. When you start out with a hamburger and you consume half of it, you only have half of it left, so that's a negative value. Okay, so this idea of consuming is negative. So anyway, the car consumes 10 1/8 gallons of gasoline. All we have to do is go back 10 1/8. So we have 1, 2, 3, 4, 6, 7, 8, 9, 10, and then here's 1/8 right about there. Okay, so what do I have left? I have 1. Oh boy, I have no room. That's what I don't have here. I have 1 7/8 gallons left, and that's about right there. Again, it's not to scale, but you can make yours to scale. Hard one to make to scale with such large numbers, and eighths are quite small, and they take up a lot of, all those eighths kind of jumble things up on a number line. But anyway, yeah, so again, 12 gallons you started with, consumed 10 1/8, end up with 1 7/8 left. Okay, so here's the letter C. Let's get this one done. Okay, so a fish was swimming 3.5 feet below the water's surface. And this right here, if we have below the water surface, we know we are talking a negative value, hopefully. And again, you didn't have to, but maybe some of you decided to use a vertical number line. They end up taking up a lot more space on your paper, but yeah, that might be fun just to actually model that idea of water. And I'm going to go ahead and do this because I feel like this is here is the surface of the water, and that's at 0. Okay, and 0 would, in this case, would represent sea level. Okay, right there. So there I am. That's what my boat might be floating on top of that. You know. Okay, but below the water surface, we know there is a fish. Okay, a little fishy. They're telling us, and this fish is sitting at 3.5 feet below. So that's a negative 3.5. So let's go down there, and that's about right there. That's where the tail of our arrow is. That's negative 3.5. Okay, 4 hours later, the fish was at a depth that is 5 1/4 feet below where it was at 7 a.m. Okay, so where it was at 7 a.m. is right there at negative 3.5. If I go another 5 1/4 feet down, because it's below that point, so that's going to be a negative. So I've got to go down, so I'm going to go down. There's 1, there's 2, there's 3, there's 4, there's 5, and then another fourth foot. Okay, kind of hard to tell where exactly that is, but that's right there, and that's at about 8 3/4 feet. So now we've gone down. Now we're down to negative 8 3/4. Okay, so that's 8 3/4 feet below. So we started here at negative 3.5, 8 3/4 below below the surface of the water. Okay. So it asks you here then what rational number represents the position of the fish. Now the position represents the position of the fish with respect to the water surface at 11 a.m. Okay, it doesn't ask you for distance between the two spots. It just asks you which one represents the position, and that would be, of course, be this number, because that's where it is. It's 5 1/4 feet below where it was at 7. It was there at 7. And now it's here at 11. Okay, and as an equation, that would be, of course, would be negative 3 1/2, because that's where it started, and then we're going to be the sum of that and another negative 5 1/4. Okay, and that, of course, adding two negatives is going to give you a negative, and that's going to be negative 8 3/4. Okay, so this fish is now at this point 11 a.m. 8 3/4 feet below the water's surface. Okay, we'll close out here with this lesson summary before you do your problem set and your exit ticket. The rules for adding and subtracting integers apply to all rational numbers. That's a big point of this, is that we learned about integers first. Why did we learn about integers first? We learned about integers first because they're easy, they're whole numbers, but it takes us into that realm of negative and positive. The next point here, the sum of two rational numbers. For example, these two, -1 and 4.3, can be found on the number line by placing the tail of the arrow of an arrow at -1, because it's at first, and locating the head of the arrow 4.3 units to the right, because it's positive, at the sum, which is 3.3. Okay, so again, we've done a number of these, but just for shakes here, we'll just go ahead and do this. If we have our -1, there's our 0. Okay, 1, 2, 3, 4, 5. All right, 1, 2, 3, 4, 5. And then we're going to go 4 and 4.3 to the right because it is positive. We go 1, 2, 3, 4, and then 0.3 is going to be right there, and we end up at 3.3. Okay. All right, so this last point right here, to model the difference of two rational numbers on a number line. For example, these two they give you here. First, rewrite the difference as a sum. So -5.7 plus -3. Okay, again, really important, because this is what we do most of the time. If we talked about this before. And then follow the steps for locating the sum. Place a single arrow with its tail at -5.7. Okay, and then the head of the arrow 3 units to the left. Okay, because it is negative in nature, to arrive at -8.7. Now I'm not going to go ahead and do that one because these are all pretty similar. The point they're making here is this is a term, we're talking about sum here, difference here. A sum is already written as a sum. A difference you need to change into a sum. It just works that way. It's going to make a lot more sense to you when you see these things in the future. Okay? Well, I hope you enjoyed this lesson. It was nice and quick. So if you go ahead and do your problem set, exit ticket, and you'll be done for the day. And see you next lesson.